الله الرحمن الرحيم. Welcome to this lecture in which that we are going to speak about the power series. First of all, we can define the power series as a series of the form sigma of Cn x to power n. In expansion, we can write it as C0, C plus C1 times x to power 1, C2 times x to power 2 plus C3 x to power 3, and keep going in this pattern. So it is sigma of Cn, the coefficient, multiplied by x to power n, or we can write it in more general form as sigma of Cn x minus a to power n. This is the general form for the power series. The sigma of Cn multiplied by x minus a to power n, which is equal to C sub 0 plus C1 times x minus 1 to power 1 plus C2 x minus 2 or x minus a to power 2, like this. And we call this is the power series centered at a. A is a real number. So this is the definition of the power series. It is a power series of this form, sigma Cn times a x minus a to power n, where a can be a real number. For example, we have this is power series x, or sigma of x minus 3 divided by n. And what is important about the series or power series in general that we need to speak about, or to check the convergence of the power series, to check whether it is convergent or it is not. And to check the convergence of the power series, we need to apply one of the tests for the power series. That one of them is the ratio test, for example, or root test. To explain or to make this more clear, check the convergence of the series x minus 3 to power n divided by n. So we need to check for what values of x does the series x minus 3 to power n divided by n converge. And later on we will speak about the radius of convergence and interval of convergence. Now to check the convergence of this series, and from which that we can find the values for x in which the series is convergent, we apply the ratio test. So by applying the ratio test, that is a n plus 1 divided by an, which is equal to. So when you consider x minus 3 to power n divided by n, this is an, and to find n plus 1, replace n by n plus 1. So this will give me, it is x minus 3 to power n plus 1 divided by n plus 1. This is n plus 1 divided by an, or we can say multiply by the reciprocal of an. Again, we have to write this an is equal to x minus 3 to power n divided by n. So this is an. So if we divide by an, means we multiply by the reciprocal of the fraction. It's equal to, or multiplied by n divided by x minus 3 to power n. We simplify this one. X minus 3 to power n plus 1, we can cancel this x minus 3 to power n. So the remaining will be only x minus 3 to power 1 times n divided by n plus 1. Now take the limit for this rate. The limit for this one, which is can be written as x minus 3 times n divided by n plus 1, as n goes to infinity. So we are finding the limit for this part, because the x minus 3 is independent of n, so we can deal with it or consider it as constant. So we need to find the limit of n divided by n plus 1 as n goes to infinity. But we know that this limit is equal to 1. As n goes to infinity, we can take the highest power, which is n divided by n, which is equal to 1. So I will have x minus 3 in absolute value. Now, by the ratio test, this series is convergent if the ratio test is less than 1. So this series will be convergent if x minus 3 or the absolute value of x minus 3 is less than 1. So we have inequality. So it is convergent if this condition is satisfied, which means minus 1 less than x minus 3 less than 1. So I can move minus 3 to the other side, add plus 3. I will have minus 1 plus 3 is 2, less than x less than 4. So when x is greater than 2 and less than 4, then the series is convergent. So it is convergent for this value, x between 2 and 4. In some cases, we need to check also the end points. What about if x equal to 2 and x equal to 4? Is it convergent or not? If I replace x by, for the end point, if x equal to 2, go back and replace x by 2. I will have 2 minus 3 to power n. So this will be sigma of 2 minus 3 to power n divided by n, which is equal to sigma of minus 1 to power n divided by n. But this series is convergent. Similar to that telescoping series, this is convergent. Similarly, for the other endpoint, we can check x when x equal to 4. I will have sigma of 4 minus 3 to power n divided by n, which is equal to sigma of 1 over n. But this is diverge. You know this one. Harmonic series diverges. So it means the interval of convergence 2 is included, but 4 is not included. So we can say when x is greater than or equal to 2 and less than 4, the series is convergent. So we can say the interval of convergence for this series is 2 and 4. So when x is greater than or equal to 2 and less than 4, then the series is convergent. Let's have another example. About that, we need to find the values for x for this series for which the series is convergent. Again, we need to apply the power series. Sorry, not the power series, the ratio test. By the ratio test, so I have limit of n plus 1 divided by in, which is equal to, this is as n goes to infinity, is equal to the limit of n plus 1 means this n plus 1 factorial multiplied by x to power n plus 1 divided by n factorial x to power n as n goes to infinity. So this one, we simplify it. I will have limit of n plus 1 divided by n factorial, this will give me only n plus 1. We divide because we know that n plus 1 factorial, just to make it clear, is equal to n plus 1 multiplied by n factorial. We divide by n factorial, so n factorial will cancel n factorial. So the remaining will be only n plus 1. So it will be limit of absolute value of n plus 1 multiplied by x to the power n plus 1 divided by x to the power n will give me x as n goes to infinity. Can be written as limit of n plus 1 multiplied by absolute value of x as n goes to infinity. But this will go for infinity. When n goes to infinity, the limit will be infinity. Which means this series comprises only if x equal to 0. Or we can say more generally, this is equal to, when x is not equal to 0, it will be diverged. It's not only, okay? This converges for we can say for any x. Not equal to, of course, for any x except the 0. So this is only will be converged for x equal to 0, or it can be, or we can say diverges for any x except this one. Because when x is not equal to 0, the limit will go for infinity. But when x equal to 0, this term will be equal to 0, and the limit of 0 will be equal to 0. So it is only converges for x equal to 0 and diverges for x not equal to 0. So this is the only condition for this for x in which this series is convergent. So now we can speak or give the general remark for the convergence of power series. You can say that for the power series, if I have Cn multiplied by x minus n a to power n, you can say there are only 3 possibilities. The series converges only when x equal to n. This is similar to the second example. This is when the limit of the ratio test goes to infinity for any x except that x equal to a. The second case, the series converges for all x. And this is for all x. Okay, this is just right. This is if the limit for the first one, the limit of a n plus 1 divided by a n goes to infinity. Then it will be converged only when x equal to a. For the second case, the series converges for all x. This will happen if this is the first case. This is the first case. Second case, when the limit is equal to 0, then it will be converged for all x when the limit of an plus 1 divided by an is equal to 0. Then we will have the second case. This is the second case. Third case, if there is a positive number r such that the series converges if x minus a is less than r. And this will happen if the limit is equal to some finite number other than 0. So the limit of the ratio test have three cases. Either the limit will go for infinity, and in that case, the series is converged only when x equal to a. Second case, when the limit of an plus 1 divided by an is equal to 0. And in this case, the series will be converged for any value of x. And the third case, if the limit of the ratio test is equal to some finite number L. And in this case, x minus a will be less than r. And the divergence of this one will be x minus a is greater than r. In the third case, will be the positive number r. There is a positive number r such that the series converges if x minus a is less than r. Or I can say this is, we call it L multiplied by x minus a, where L is finite number. In this case, third case, we will have r, positive number r, for which that is less than r, and in the series will be converged, and if x minus a is greater than the number r, then it is divergent. For example, the geometric series, which is sigma of xn, will be converged if r is equal to 1. And this can be checked by the ratio test. And we can find the interval of convergence that will be between -1 and 1. The power series x minus 3 to power n divided by n, this is the one that we checked. This will be less, or the convergence if r is less than 1. Or sorry, if r is equal to 1, this is the radius of convergence. We call r is the radius of convergence. This r, r equal the radius of convergence, which is there. And the interval of convergence will be between 2 and 4, and 2 is included. We can say it have open or half a closed interval. The second example, which is n factorial x to power n. This is the second example we have discussed. And as we found that the series is convergent only for x equal to 0. That's what we said. It is convergent only if x equal to 0. Which means r is equal to 0. So the radius of convergence is r equal to 0, and the interval of convergence is only 0. Third example, if we have x to the power n divided by 2n factorial, then we'll see that the limit for this one is equal to 0, which means, the limit of the ratio test is equal to 0 for any x. So r will be infinity, and the interval of convergence will be minus infinity to plus infinity. And also this will be discussed in detail in the coming lecture.